So guys, going forward, ARP protocol works using two types of messages: the ARP broadcast request message and the ARP reply message. Now note that the ARP request message is actually a broadcast message, whereas ARP reply message is a unicast message. Now what does it mean by broadcast message and unicast message? You will understand when we will be discussing the functionality of ARP protocol in detail in the coming slides. ARP messages never crosses the subnet boundary. Now here ARP messages means both, that is ARP request message and ARP reply message. So either type of ARP messages never cross the subnet boundary. So for example, in this diagram, suppose host machine E issues the ARP broadcast request message and places that message on the wire. So you can see that this ARP broadcast request message will be received by all the machines present in the same subnet, but this message will never cross the subnet boundary. So the gateway L3 router of a subnet is the demarcation of subnet boundary. Whether it is a ARP request message or ARP reply message, always remember that ARP messages never ever crosses the L3 router, which is a gateway of a subnet. So ARP message will never go on the other side of this L3 router, right? So in other words, L3 router demarcate the boundary of the subnets. All machines in the same subnet are said to be neighbors. So we have already discussed this point, that all the machines which are present in the same subnet are said to be neighbors of each other. So the neighbors of the host machine E, for example, will be host machine D, host machine F, and the L3 router itself. Now going forward, now let us discuss the ARP header format specification. So you can see that this diagram shows the standard message format of ARP message type. You can see that there are various fields in this ARP message type. Let us discuss the meaning of each of these fields, which is shown in this ARP message format specification. So the first field is the hardware type. So the value of this field is set to 1 if the wiring that is being used is Ethernet cable, and if this wiring is used using optical fiber cable, then the value specified is 18. Of course, there are other types of communication channels, but these are the most common communication channels which is used in networking. And therefore, we will limit our discussion only to these two hardware type values. That is 1 for Ethernet cable and 18 for optical fiber. Then the second field is the protocol type field. Here, protocol type field represents whether the ARP resolution is being done for IPv4 address or IPv6 address. If the ARP resolution is being done for IPv4 address, then this value is 0x0800, that is the hexadecimal value of this field will be 0x0800. Then hardware address length. This value is 6 bytes. Of course, the hardware address is always the MAC address. The most common hardware address that is used in networking today is MAC address, and the length of the MAC addresses are 6 bytes. Therefore, the most common value of this field is 6 bytes. Then the next field is the protocol address length field. So simply, if the ARP resolution is being done for IPv4 address, then the value of this field is 4 bytes. And if the ARP resolution is being done for IPv6 address, then the value of this field is 16. Right? So it is some typo mistake here. So remember, this field represents the length of the protocol address. So what is the length of IPv4 address? The length of IPv4 address is 4 bytes, right? And the length of IPv6 address is 16 bytes, right? Now the next field is the opcode. This opcode represents the type of this ARP message. That is whether this ARP message represents ARP request message or it represents ARP reply message. So if the value of the opcode is 1, then this message represents the ARP request message, and if the value of the opcode is 2, then this message represents the ARP reply message. So remember, the same message specification format can be used to represent ARP request message or ARP reply message based on the value of opcode. Then the next field in this message format is the sender hardware address. You can see that the size of this field is 48 bits. That is 32 bits plus 16 bits. So the total size is 48 bits. And this field represents the MAC address of the sender. Sender means a host machine which is generating this type of message, that is ARP request message or ARP reply message. So this field will be the MAC address of the sending machine. Then the next field is actually a 32-bit field which actually represents the IP address of the sending machine. So you can see that the specification allows you to specify only 4 bytes to specify the sender's IP address. Therefore, sender protocol address can only be IPv4 addresses. And the next field is the target hardware address. So this field represents the recipient MAC address. That is the MAC address to which this message is destined to. And the final field is the target protocol address, which is actually the destination IP address for which this message is destined. So it will be the recipient IP address. It is not IPv6 address, it can only be IPv4 address, because you can see that the message specification allows you only to specify 32 bits as a target protocol address.